just some basic quadratics, how to use the graphics calculator, and then we'll try and do some word questions. But rather than doing word questions, I'm going to just introduce the concepts to you guys, because I think just starting from a word question is actually not a great idea. So to kind of give you guys, get you started, the first task that I'm going to ask you guys to do is this. If you know how to actually come up with the equation of this quadratic, I would like you guys to actually try this out. Okay? I've asked you guys to find the equation for this quadratic. Now, I will give you guys some little tips here. I know the screen looking from the audiences there is a bit tough, but basically, we've got a few points here. This one here is -1, 0. This one here is -4, 0. And also remember that you got to pick a point that's that you're absolutely confident in. So I would actually say go along the graph and look for a point that's pretty obvious. Now I guess this one here right there is a good choice. So that point there is 0, -8. So those are the 3 points. As for the vertex, you've also got a vertex here, which I'll give you, which is -3, -13. Okay, so those are the points that you're working with. Oh, sorry, not -3. It's actually -1.5. So I'll give you guys just a couple of minutes just to have a look at how you're going to come up with an equation for this. In about 2 minutes, what I'll do is I'll actually go through the... Where have I made a mistake at? Oh, yes, thank you. Thank you. Sorry, that should be +1. Yes, you guys are right. Is that all right? So you're comfortable with it, right? So I'm going to show you guys 3 methods. 2 of them is without using a graphics calculator, and the third one is using a graphics calculator. All right? Now, what I generally tell my students is this: if you're doing Mat 2, then get into the habit of actually doing it without a graphics calculator. Especially if you're doing algebra next year, it's a really good idea to do it without a graphics calculator. So the first method that I'm going to walk through is Vertex Form. All right. Now, a lot of you guys might have actually learned this in a different way in your books. Your teachers might have done it slightly different as well. I do it in my own way as well. But believe it or not, whatever way you choose, you're still going to end up with the same kind of answers at the end. So with the vertex form, this is the general equation that I use. Now you might have actually seen it as with different letters instead of H and V. The reason I use H and V is because H being the horizontal movement, V being the vertical movement. All right, when I say vertical, it's going up or down, H going left or right. So one thing to know about the vertex is usually the point HV. So in this case, let's see if that works. Yep. This point right here, that's the vertex. It's also known as the turning point, right? So I'm going to replace my H and V with those 2 numbers there. So this is H, and the number after it is the letter V. So I could write this equation as y equals a, x minus, I know what h is. H is -1.5 squared plus v, which is -13. All right, all I've done is I've taken my h value there and substituted it here, and I've taken my v value there and substituted at the end there. So this can be simplified now as a x plus 1.5 squared, not plus, minus 13. Now, I've actually figured out almost everything. I need to figure out what that a value is. To figure out the a value, I need to choose a point to substitute into this equation. So I could literally choose, I'm going to see what colors have I got here. I could either choose this one, or this one. It doesn't matter which one you choose. All right? They all will give you a value. I'm going to use this one here. which is 1, 0. So what I'm going to do is I'm going to substitute x as 1 and y as 0. So when I do that, I get 0 equals a, and then I've got x is, what is it, 1 plus 1.5 squared minus 13. Is that okay so far what I've done there? So the next step is rewriting this as 2.5 squared minus 13, and then 2.5 squared is, I can't do it in my head right now, 6.25. Is that right? Have I made a mistake? It doesn't look right though for me. So then I've got a times 6.25. Oh, I know what I've made a mistake. Can you guys tell me what mistake I've made here? Go on, find it. I know what the mistake I made. I just figured out what it is, but can you guys see it? The vertex is wrong, isn't it? Why is it wrong? It's actually 12.5, not 13. Because look, that's 10, that's 12. Yeah, it's sorry about the resolution, guys. That shouldn't be 13. That should be 12.5. It's all right. Nothing changes because all that 13 changes to 12.5. Okay, so rearranging this, I've got 6.25a equals to 12.5, and then a is equal to 12.5 divided by 6.25, which means a is equal to 2. So the equation that I have is y equals 2 x plus 1.5 squared minus 12.5. Now that is doing it through the algebraic way. I'm going to take a little break and I'm going to show you guys how to do it using a graphics calculator. How many of you got a graphics calculator here? If you do, take it out, switch it on, and I'm going to show you guys how to use the graphics calculator for this problem. And again, with the graphics calculator, it's really important that you guys get those correct points. Now, I made a mistake here. You know, I used 13 instead of 12.5. That means my graph equation might not actually be correct. But anyway, what you want to do is create a little table, call it X and Y, and write down those whatever points that you're absolutely sure about. So the points that I'm sure about is -4, 0, 1, 0, 0, -8, and -1.5 and -12.5. Now let's say you're not sure about that last point. Okay, we're not going to use this last point. Let's just see what happens when we don't use that point. What I'd like you to do is open up your graphics calculator. Okay, I will try and go slow with these instructions, guys, but trust me, it makes a hell of a lot of difference. Click on menu and go into the stat mode. Now, if at any point you want to press enter or your return key, that's the little blue button right at the bottom of the graphics calculator. All right, once you go to stat mode, press enter and you should see list 1 and list 2. Now, if I do go fast, I've got 2 teachers on the side there that can actually help you guys out with these instructions as well. Basically, what you want to do is in list 1, you want to put all the x values. In list 2, you want to put the y values. So, -4, 1, 0, those are all my x values. And my y values, it's 0, 0, and -8. Okay, once you do that, the next part you want to press is F1, which is above that little shift yellow button there. If you press F1, it'll come up with 3 more little options like this. Just press F1 again, and it's going to show 3 points in your calculator looking like this. If you press F1 again, which is says calc, you should end up with a screen, bottom of your screen should look like this. And I think if you see F4, it should say x squared. So if you press F4, that should actually give you the values of A, B, and C. Now, for those of you that are wondering what the hell is ABC, if you look at the bottom of the very last line in that screen, it actually gives you the equation of a parabola, which is ax squared plus bx plus c. So you could write your answer like this. A is 2, 6, negative 8. Because A equals 2, B equals 6, C equals negative 8, you could write your answer like this. Because remember, this is the format. Ax squared plus bx plus c. So you can rewrite this as y equals 2x squared plus 6x minus 8. And for those of you that have done algebra and are really comfortable with this, you guys could try and expand this. And if you expand it, what you'll notice is you should get the same answer as this. All right? So both of these answers are correct. One of them is in vertex form, and the other one is in standard form. Is that all right? Can I give you another question like this, real quick one, and then I want to move to another slightly different version of this question? Yeah? Okay. Actually, no. I'm actually going to show you guys one more thing. What happens, and this is something that I've seen pop up every now and then. So see this parabola here. What happens if the parabola is shifted up by 3 units and shifted right by 2 units? Do you guys know how this would actually work out? If you do know it, have a go. If you don't know, have a go as well. Just to see what type of mistakes you make. I'm going to give you only 30 seconds for this. So what happens to this equation if this entire parabola is shifted up by 3 units and shifted to the right by 2 units? Okay, I'm hoping you guys have had a chance to look at it. What I'm going to do is I'm going to write just the answers, and I want you actually to see where the changes happen from. So this is the answer I was looking for. Okay, what do you guys notice? Have a look at it. Have a look at my answers at the bottom in the blue. The green was the original equation. I'm hoping you guys can see some sort of pattern here. Okay, so what's happened here is this. When you shift right side by 2 units, this, whatever in the x, has actually changed. And when you shift up by 3 units, this last value here has actually changed. Can you guys see that? So it doesn't matter whether it's a quadratic, whether it's a linear equation, whether it's an exponential equation. There is a general rule. And this is something that I did on Friday with my class, is this. If something is moving up, then you just add. Like say if it goes 3 units up, then you just add 3 to the equation. If it moves down 3 units, then you subtract 3. Okay? But if it goes right side 3 units, then look at wherever the x is. So you got to find x and replace it with like x minus 3. Or if it goes to the left side, find x and replace it with x plus 3. I think there was a similar slide like this in my Friday tutorial if you want to have a look at it. But this actually works for any kind of equations, whether it's quadratic, whether it's exponential or linear. All right, one more quick question like this. I'm only going to give 5 minutes for that one. And then I want to get into some like contextualized quadratic questions. Can I move on from this slide, guys? Real quick one. This is question number 2. Just going to wrap this up real quickly. So we've got 3, 0. Okay, I want you to come up with the number 1, equation of the parabola. Number 2, shift. And I'm going to put number 3 there as well. Yep, my mistake. That should be 7, -8. Sorry, guys. So basically what I'm going to do is I'm going to do the graphics calculator version first, just so that we kind of know what we're doing here. So put my 3 x values. So I've got 3, 7, 11. Three, 0, 11, 0, 7 minus 8. Wow, that's weird. Okay. Graph 1, calc. Have I made a mistake again? 3, 0, 11, 0, 7, -8. Does that look right, folks? Lovely. I'm not getting one single yes. So I've got my equation in which format? In the quadratic format. So fill up my A, B, C values, which is 0.5x squared minus 7x. Okay, those of you that did the graphics calculator, are you okay with that? Sweet. I bet you want to see the vertex form, yeah? Okay, vertex form, my h and v is right there. So I can rewrite this as x minus 7 squared minus 8. I got to figure out what the a value is. So I'm going to substitute 3, 0. That's x, that's y. So 0 equals a times 3 minus 7 squared minus 8. Now 3 minus 7 is -4. Rearrange. I've got 8 equals a times 16. Which means a is equal to 8 over 16 or 0.5. So my equation here is y is 0.5 x minus 7 squared minus 8. Is that all right? Cool? Now, we were doing 2 units left and 3 units down. I'm gonna need a refresher. What was it? 2 left. Is that right? Okay. So with the first equation, I've got y equals 0.5 x minus 7. Now because it's going 2 left, I got to do plus 2 squared minus 8, and then it's going 3 down, so minus 3. Simplifying this, I get 0.5 x minus 5 squared minus 11. Now let's say you use the graphics calculator. If you use the graphics calculator, you need to do this. Y equals 0.5. It's 2 left. So x plus 2 squared minus 7 times x plus 2 plus 16.5 minus 3. So that simplifies to this here. Is that okay for number 2? I'm assuming that's a yes. I'll take that as a yes. Number 3. We got P units right. And Q units up. Okay, guys, I know everyone here has probably got this one, but can I get you guys just to have a look at this one, please? Because this was an excellence question a couple of years ago, and even last year, I think there was a question like this for exponential equations, but still, same idea. So, we got P units to the right, which means we need to write it like this. Y equals 0.5. We already have x minus 7. And because it's going P units to the right, we're going to write that as minus P. And then it's going Q units up, so plus Q at the end. And then if you look at the other version, you've got 0.5 x minus P squared minus 7x minus P plus 16.5, not P, and plus Q right at the end there, because it's actually going Q units up. Good question, Zach. If they say, give the equation of a quadratic, like if they say, give the equation of this graph, they don't really say what form, then this one is correct. But if they say, give the equation of this graph in a vertex form, then you have to give it in this format. Okay, so it depends on how they ask the question, and I can't really predict how they're going to ask it. Now there is one other form called intercept form, but we've kind of hardly see it pop up every now and then, but we do see the vertex form. It's like they ask you in vertex form or they ask you to come up with the equation. Okay? Any more questions on this? Okay, so the next part, what I'm going to do is I'm going to take one of last year's word questions, but I'm going to draw it up in a scenario, and I want you guys to try and answer this, all right? So basically, this is the problem right now. We got a guy that's standing right here, okay? We are obsessed with kicking footballs and rugby balls because that's the only thing that seems to have a parabola shape. Okay? Here's the situation. I'm going to tell you guys a story, so you need to listen. A guy that's actually kicking a ball. He kicks the ball and it lands about, I don't know, let's say 50 meters. Okay? So it lands after 50 meters. I also tell you, maximum height this ball reaches is, I don't know, let's see, how high can this be? This is about 30 meters. Now let's say 25 meters here. Okay? If I ask you guys to come up with an equation of this, equation for this parabola, would you be able to come up with it? Okay? All I'm telling you is this. He kicks it from this point right here. It lands 50 meters later, we also know the maximum height this ball reaches is 25 meters. And that's all I'm going to tell you. And what I want you to do is, can you come up with an equation for this? So actually, no, I'm going to give you guys 2 hints. The first hint is this. Make this point 0, 0. The first hint. The second hint is this. If you make that 0, 0, there's your x and y axis. But rather than calling it x and y axis, we might call this, I don't know, G for ground and H for height. So that's H, that's G. So what would the equation then look like? Now, even before you go to the equation, let's have a look at some points. You got 0, 0 is 1 point. Can you come up with another point? 50, 0? 50, 0 is another point. What's another point we can come up with? 25, 25. Why did you go 25, 25? Yes. Yeah, sorry, 50 meters on the ground. So 25, 25 is that middle point right there when the ball's at the highest of its peak. So I'll leave this question for you guys. Come up with an equation of this parabola. So with the vertex form, I've got H and V here, which is 25 and 25. So I can rewrite this as, instead of Y, I'm going to use H equals A. Now instead of X, I'm going to use G. So G minus 25 squared plus 25. Now the easiest point to substitute in this case would actually be 0, 0, not 50, 0. Pick 0, 0 because it makes it simple. So when G is 0, H is 0. So we got 0 equals A times negative 25 squared plus 25. So we got A equals negative 25 times 625. I'm hoping you guys got 1 over 25 or 0.04. Yes? No? Okay. 1 shake of head. That's good enough for me. For those of you guys that did the graphics calculator way, you guys should have got this. Yep. Oh, yep. Sorry. Thank you. Sorry. Negative 0.04. We're good with that, guys? For those of you guys that use the graphics calculator, that it kicks the ball, it travels 50 meters, reaching a maximum of 25 meters height. Let's say we're using the same 2 equations, all right? We're using the same 2 equations, but I'm going to go back to this graph here. And we're going to put a couple of goalposts here. Let's say right there. All right? And this goalpost, are we listening, folks? Because this part is important. The goalpost is actually 40 meters away from him. So that distance there is 40 meters above him. And I think if I'm correct, the height of the goal thing or whatever it is, that part right there. I'm going to try and draw a 3D image on a 2D image, but you guys get the idea. Okay? So that height of that little bar is, what would it be? 2, 3, maybe 3 meters. Let's chuck in 3 meters. So my question is this ball going to go above the bar or below the bar? And how would you actually find it? Now, I know in my diagram it looks like it, but don't look at my diagram. How would you actually do this? And because of the time limit, I got to show this to you guys. Basically, we have the ground distance is 40. Does that make sense? So we're trying to figure out, we know the ground distance is 40, and we're trying to figure out what the height is. So that means we go back to our two equations here. We put g equals to 40 and find out what h is. G equals 40 here. Find out what h is. Can you guys do that for me? And tell me if it's above 3 meters, then yes, he's going to make it. If it's below 3 meters, it's going to go underneath the bar. So can you guys try and work it out for me? I'm only going to give you guys 1 minute because we got to wrap this up in 2 minutes. Okay, I'm going to show you guys how to do this real quickly in by hand, and I'm also going to show it to you by the graphics calculator as well. So with the first one, it is just substituting. So I'm going to put negative 1 over 25, 40 minus 25 squared, plus 25. So solving, you got 15 squared plus 25. 15 squared is 225. Negative 225 divided by 25 plus 25. We got negative 9 plus 25. 16 meters. Okay, that's a yes from one person. I'm good. So has this, is he going to make the shot? Yeah, because we said the height was 3 meters. He's actually got 16 meters. So it's well above it. Now I'm going to show you guys this real quickly because I know I'm keeping an eye on the time. How to do this in the graphics calculator. So, I don't know if this will work. I'm going to try it anyway. When you see this little equation, right? What you can do is see that little button that says copy, and there's also a button called draw. I think if you press draw, it actually shows you the graph. Now at this point, the bottom of that screen is going to look like this. What you do is you press shift, and you'll get to this little button under F5 called G-solve. All right, and if you click on G-solve, there's a button that says Y-cal. You click on that. I thought this was supposed to work. Oh, yep. You put X equals to 40, and you press enter, and it gives that value Y equals to 16. Okay, now I know I went pretty fast on that, but that is recorded. So I'll chuck it up on YouTube tonight so you guys can actually watch it later on, all right? That's it from me, guys. I'll see you back sometime this week.